Number 24 on the practice exam, a NCAA men basketball coach uses a new technique to train basketball players' free throw accuracy. 7 players were randomly selected from a large population of NCAA basketball players, and their free throw accuracy scores are recorded before and after the training. The results are shown below. So these are the 7 subjects, A, B, C, D, E, F, G, 7 players. This is their free throw accuracy. So player A 77 before the training, and then after is the very last row. All right, the biggest giveaway that you're gonna you'd be using to determine if it's a match pair or 2-sample t-test. The biggest giveaway is that it's a before and after thing. So you want to measure what the results were after the training, if there was an improvement or not. And the question continues. It says, do the data suggest that the training technique is effective in raising the player's free throw accuracy scores at the 5% significance level? So what you're trying to decide, what you're trying to test is, if this free throw training is actually doing the players any good, if it's improving the free throw accuracy. Some of the other techniques to determine if it's a match pair or 2-sample t-test. Usually, match pairs, the two things that you're comparing are usually coming from the same population, and in 2-sample t-tests, they're usually from different populations. So an example of that is you're comparing men and women population, so that's why it'd be a 2-sample t-test. To really be confident in determining what's match pair and what's 2-sample t-test, just go back and look at the slides in the lecture, and read about match pairs and read about 2-sample t-test. Anyway, we got to answer this. So to set it up, our null hypothesis is that both before and after, again, when we talk about null hypothesis, is that there's no difference, right? There's no difference. So if there's no difference, before and after training, the player's free throw accuracy is the same. So the difference between before and after is 0. And then our alternative is that this training actually does the players good. They do a player good. So we say that the difference is going to be greater than 0. Or we can say that, the mean for after is greater than the mean for before. And then we select 0.05 for alpha level because it says right here 5% significance level. The test statistic, again, you can do it by hand. The easiest way is to use the calculator, and let me show you how to use the calculator really quick. Just go to stat and plug the information in your list. So before, let's put all this information in the before list. And then what you're going to have to do is calculate the difference, between the two. And then in list 2, we go 78, 69, 86, 75, 88, 68, 65. All right, and then list, what you're going to do is you go to the very right, to just the list 3, and you highlight the list 3 part. So follow my calculator. See how list 3 is highlighted? Once you're there, you go list 2 minus list 1. Enter. And this is the difference. This is subtracting 78 minus 77, which is 1, 69 minus 67, which is 2. So the calculator just did that for you. And then go to stat test, and you're doing a t-test, right? Because these are samples. These aren't informations about the population. So it's a t-test, match pair t-test. Press enter there and go to data because all your information is in the data. Mu naught is 0, and all the differences between the two lists are in list 3. Frequency, keep that at 1, and then you're testing if it's greater than 0, and then you calculate. And there's your t. Your t is 0.87, and your p-value is 0.206. Now, because your p-value is 0.206 and you're comparing it to 0.05, your p-value is greater than your alpha, and whenever that's the case, you fail to reject, and then you make a conclusion. And the conclusion says the data doesn't suggest that training technique is effective. So that's it. Use the calculator and make sure you make a good conclusion.